Hi everybody. Today we're going to talk about some different triangles. So to begin, I just want to talk a little bit about what we know about isosceles triangles. We don't know a whole lot, but if you remember from the definition that I gave you guys a week or so ago, you know that an isosceles triangle has at least two congruent sides. So remember, we call those legs, so those are going to be our two congruent sides. Today, our focus is going to be 4.6, talking about isosceles, equilateral, and right triangles. Today, we are going to focus on isosceles and equilateral triangles. So, there's a couple different parts of this triangle that you guys should know. Hopefully you guys remember that these two congruent sides are legs. So there's a leg and there's a leg. And we touched on this, that this down here, the side that is not a leg, is called the base. So hopefully it would make sense that these angles down here that are on the base are what we call base angles. And the last part that you guys need to know is this angle up top in between your two congruent sides, or those legs. These are what we call a vertex angle. So, learn these parts, know them. We'll talk about them and use those in different ways. So, make sure you have these parts down. The legs, the way I remember those, there's two of them. You have two legs, so those are going to be the two congruent sides. Like I said, the base angles are going to sit on the base. Should make sense since they're right there. Then, we got a couple theorems we're going to talk about. First of all, the base angle theorem. The base angle theorem says that if two sides of a triangle are congruent, so we have an isosceles triangle, then the angles opposite them are congruent. So in our picture here, we've got side AC and side AB being congruent. So this angle and this angle here are going to be our congruent angles, angle B and angle C. That's helpful for us, definitely with some proofs and solving some different problems. So that one is a good one to keep in mind. And then we've got the converse of the base angles theorem. If I know that angle B and angle C are congruent, then I know that side AB and side AC here are going to be congruent. So just helping us show that we've got isosceles triangles and properties of them. So we want to use the diagram of triangle ABC that we're given here to prove the base angle theorem. We're given that ABC, we're given triangle ABC, and we're given that AB is congruent to AC, and we need to prove that angle B and angle C are congruent. So we set up our two-column proof. Got our statements and our reasons, and we'll split that here. So, first thing, we always start with the same thing. We are going to start with our given. So we're given triangle ABC, and we're given that AB is congruent to AC. Reason being given. Next thing we're going to do, and this is something that we haven't talked about before, so this is a little bit new. But what we're going to do is we're going to draw the angle bisector. Angle bisector of angle BAC. The reason being, it's what's called a construction. It allows us to put in that angle bisector. And if I remember right, I think I showed you guys how to do that construction with a straight edge and a compass at the beginning of the year. So that's what we're going to do next, so that we can say next that angle CAD is congruent to angle BAD. The reason being is, since we drew that angle bisector, that is the definition. Of the angle bisector. So now I know that this angle is congruent to this angle up top in our diagram, and feel free to mark those off. So next step, well, we need to show that these two we've split it into two triangles now. We need to show that those are congruent. Well, the next step, I know that AD obviously is congruent to AD. AD is congruent to AD. And that is our reflexive property. So we have a side, an angle, and a side congruent. That angle is the included angle in between those two. So step 5, I can now say that triangle CAD is congruent to triangle BAD, and that is by the SAS congruence postulate. And now, since I know that these two triangles are congruent, now I know that all the angles and all the sides, even though I haven't shown that, so I can go to step 6 and say that angle B is congruent to angle C, and that is CP CTC. So corresponding parts of congruent triangles are congruent. Nice little math tongue twister for us there today. So now I know that angle B and angle C are congruent. So that is our base angles theorem. So obviously we can't use the base angles theorem to prove the base angles theorem. So it's a long way of getting around that. Feel free to use that base angles theorem as you need from now on. We're going to talk about some corollaries. So remember, corollaries are what come right after theorems. So just kind of a little mini thing that we're dealing with. Corollary theorem 4.6. If a triangle is equilateral, then it's equiangular. You can look at any two sides, and those base angles would have to be the same. So since I really have 3 equal sides, I've got to have 3 equal angles. Going the other way with that, if I know that all my angles are the same, then the triangle has to be equilateral. Again, just some more helpful information to help us solve some problems. Last thing we want to do today, we need to find the value of x, we need to find the value of y. So, what I can do is, I know I'm going to do all my work for part A in blue. I'm looking at this triangle here. I have what appears to be, since I have congruent signs here, an equilateral triangle. So that means from my corollary that we just talked about, all angles are x degrees. Well, if I add all those up, I get that 3x is equal to 180. We know that all angles of a triangle add up to 180. Divide by 3, and get that x is equal to 60. Now, we need to, that's a nice little easy one for us. B is going to take a little bit more work. So if I know that this angle here is 60, then this angle here has to be 120 because it's on a straight line that measures to 180. Also, I have this side is congruent to this side. So I have an isosceles triangles, meaning that my base angles are the same. Since one is y degrees, the other one must be y. So I get that 2y plus 120 is equal to 180. And we can solve from there. Subtract 120 from both sides. You get that 2y is equal to 60. Divide both sides by 2. Get that y is going to be 30. So just look for those different types of triangles. That's what's really going to help you here. And we can solve these triangles using different properties of isosceles and equilateral triangles. So here's your homework. It's also posted on my website and in the back of the room. If you have questions, let me know. I'll do my best to answer them as time allows. So here it is, page 240, number 8 through 25, working in section 4.6. Thanks for watching. Have a good day.